Formula of a compound and number of voids filled. It is found that number of voids present in closed packed structure depends upon number of spheres or atoms present in it. If the number of spheres present in closed packed structure is equal to n, then number of octahedral voids generated will be also equal to the same number, that is n, and the number of tetrahedral voids generated will be equal to twice the number of atoms present in the closed packed structure, that is 2n. Now let us try to solve the first question. According to the first question, the element y is occupying all the lattice points in the closed packed structure, and the element x has occupied all the tetrahedral voids in the structure. We know number of atoms present in the closed packed structure will be equal to number of octahedral voids generated. So both the elements x and y will be of equal ratio. So formula of the compound will be equal to xy. In the second question, atoms of element B has occupied all the lattice points in the hexagonal closed packed structure, whereas the element A has occupied only 2/3 of tetrahedral voids. We know number of tetrahedral voids formed will be equal to twice the number of atoms of element B. And in the question it is also given only 2/3 of the tetrahedral voids are occupied by atoms of element A. Hence the ratio of the number of atoms of A and B will be equal to 2 into 2 by 3 is to 1 or 4 by 3. Hence the formula of the compound will be equal to A4B3. Now let us verify number of tetrahedral voids generated is equal to twice the number of atoms present in a closed packed structure. For that, let us take the face-centered cubic unit cell. From the figure you can see each FCC unit cell has 8 small cubes in it, and each small cube has 4 atoms. Those atoms are represented using red color balls. When you are going to join those 4 atoms in a cube, you get a tetrahedral void. There are 8 such small cubes in the unit cell, so you can generate 8 such tetrahedral voids. And we also know number of atoms present in the face-centered cubic unit cell is equal to 4. Thus, you can very well verify if number of tetrahedral voids is equal to 8, then the number of atoms present in that unit cell will be equal to 4. Now let's check whether the number of octahedral voids generated is equal to number of atoms present in the closed packed structure. For that, let us take the FCC unit cell. In FCC unit cell, octahedral voids are of two types. One formed at the body center and the other one formed at the edge center. Let's see how the octahedral void is formed at the body center. When you join 6 atoms on the 6 face centers, an octahedral void will be formed at the body center. This is shown in the figure 1. This octahedral void at body center belongs exclusively to that unit cell. It will not be shared with any other unit cell. Now let's see how the octahedral void is formed at its center. When you join 2 corner atoms and 2 face center atoms of one unit cell with two atoms of two adjacent unit cell, an octahedral void will be formed at the edge center. In FCC unit cell, we know we have 12 such edges. So, 12 octahedral voids can be formed at the center of each edge. These 12 octahedral voids will be shared with 4 other unit cells. So, number of octahedral voids present in the FCC unit cell will be equal to one octahedral void present at the body center plus 12 octahedral voids present at the edge center, each shared with 4 other unit cells. So, 12 into 1 by 4, which will be equal to 3. So, 1 plus 3 will be equal to 4. We also know in a FCC unit cell, number of atoms present is equal to 4. So, we have 4 octahedral voids and 4 atoms present in the FCC unit cell. Thus, you can prove number of octahedral voids is equal to number of atoms present. Let us summarize what we learnt. We have proved that number of atoms present in a closed packed structure is equal to number of octahedral voids generated. And we also proved that number of tetrahedral voids generated is equal to twice the number of atoms present in the closed packed structure. So, let's see two examples. In the first example, atom A has occupied all the octahedral voids and atom B has occupied the lattice points. We know number of lattice points or number of atoms is equal to number of octahedral voids generated. So, atom A and atom B will be of same number. So, the formula of the crystal will be equal to AB. And in the second example, atom A has occupied all the tetrahedral voids and B has occupied all the lattice points. We know number of tetrahedral voids is twice the number of atoms present in it. So, 8 atom A are there and 4 atom B are there. So, formula of the crystal will be equal to A to B.